What we're going to do now, before we watch the interesting video later, which I promise we'll watch, is we are going to finish up at least part of chapter 24, okay? Which is all about the origin of species. So I need to intro some terms to you, so here we go. Let's talk about the term speciation. Speciation is the origin of new species. So it would be the production of new species, right? And as we mentioned earlier, microevolution is when you have the evolution of a population. Whereas macroevolution would be the evolution of the entire species. This type of evolution would be one that we would see at a global level. And when we identify what a species is, I think we always want to remember that a species means that you have a group of individuals with the ability to successfully interbreed. What?
Just trying to put the date as October 10th, 2010.
Like 15 months off. Sorry, buddy. It sucks.
I'm very confused. I'm gonna go to sleep.
Okay. Let's talk about the biological species concept. And there are different species concepts out there, but if you do some reading in chapter 24, you will see that like the other species concepts to me just don't make any sense. And according to that concept, its members of the species are able to interbreed and produce offspring. And those offspring are like 100% successful themselves. In other words, those offspring are good to go. They can make their own babies later or whatever. I want you to see that, yes, the biological species concept definition is pretty much the same as a species, because when we define what a species is, we use a biological species concept. There are other species concepts out there, but again, they just seemingly don't make too much sense. Now, on this next part, what I want to do is I want to talk about different mechanisms to prevent random speciation. In other words, what are the things that are occurring in biology that would allow things like a liger to just randomly exist? And what I want us to do to complete this discussion is we'll leave about this much room, and let's do like a division like this, maybe about like 60% over here, 40% over here, and let's title this pre-zygotic barriers, and then we'll have some room for the post-zygotic barriers. Some of the pre-zygotic barriers are going to be, let's see, habitat isolation, which basically means you live in different areas. The reason the kangaroo and the American wolf don't have a hybrid is because They don't live in the same area. That's one way to stop that. Another is temporal isolation. Which basically means they're not out at the same time. Like a bat and a cow is a good one. Hard to make a hybrid there because they're not out at the same time. Behavioral isolation. Maybe certain rituals, like courtship rituals, and other behaviors don't match. You know, like a cow goes moo, duh, and a dog barks. I think those behaviors are certainly not the same. So, behavioral isolation. There's also mechanical isolation. What mechanical isolation means is that basically the units don't match. You probably understand what I mean by the term unit. Right? Okay, two people. Good. And then there's also gametic isolation, which would be when the egg and sperm are not compatible. Cool. So you'll notice that your prezygotic barriers, again, are like the different things that are preventing a little zygote of two different species from being formed. Right? Now, like the lion and tiger can form a liger because a lion and tiger could live in the same area. They could be mating at the same time. They both have about the same behaviors. Their units are close enough to the same, and their gametes don't like hate each other. In other words, the egg and sperm like do meet up. Cool. So a baby liger zygote could be formed. Tomorrow we'll talk more about how those postzygotic barriers are going to work.